Welcome back, everyone. Last time we talked about how to solve polynomials that could factor. Today we're going to talk about solving polynomials that can't factor. This is called solving polynomials the long way, and it is long, so make sure you have plenty of paper to do each of these problems. I'm only going to do 2 problems, but that'll be more than enough. So what do we do if we can't factor, if we have to go the long way? Not every polynomial will factor. Therefore, we need a method for solving ones that don't fit into our factoring techniques, that aren't perfect cubes, that aren't higher order quadratics, and that we can't group. Graph the polynomial in the calculator and find all the pretty x-intercepts. Now, what do I mean by pretty ones? What I really mean is rational ones, the ones that are either a whole number or a fraction. Divide out all the zeros or factors that you found to make a smaller polynomial. And then remaining polynomial cannot be factored further, but you might be able to solve by using the quadratic formula. So find all the ones in the calculator you can find, divide them out, and then use the quadratic formula on what's left. So we're going to have to use the calculator, polynomial division, and quadratic formula. Take a look at this problem. This one we could solve by grouping, but I'm going to do it the long way to show you how to do it. Step 1. Plug it in your calculator. Y equals the problem, and Y2 is 0. Graph it. I need 3 answers, but I only have 1. Figure out what that answer is. Second trace, 5. Get over close to it. Hit enter 3 times. And this tells me that one of the answers is 3. So I have x equals 3 is one answer, which means that x minus 3 is a factor. Now I need to divide. I can divide with long division, x minus 3 into this, or I can divide with synthetic division, where I use the 0 of 3. I'm going to use synthetic division because it's much faster. So I'm going to put a 3 here, and I'm going to put the problem, 1, negative 3, 4, and negative 12. Before I even start this, I know what my remainder is going to be. It better be 0. If it's not, I've messed up somewhere. Synthetic division. Drop. Multiply. Add. Multiply. Add. Multiply. And it cancels out. So what equation do I have left over? I have x squared plus 4. That's my second factor. So what are my factors? X minus 3 and x squared plus 4. But I didn't want your factors. I wanted you to solve it. This one's easy to solve. X squared plus 4 equals 0. X squared equals negative 4. X equals, if I take the square root of both sides, I get plus or minus. The square root of 4 is 2, but it's negative, so it's 2i. How many answers did I find? 1 from the calculator, divide 2 more from the quadratic. I found 3 answers. I needed 3 answers. I'm done with my problem. So let's review the long way again. Step 1, find all the zeros you can find in the calculator. Step 2, divide them out from the problem. Step 3, look at your last factor. Figure out a way to solve it. Step 4, either use square roots or quadratic formula to solve. Let's try a hard one. 3x to the 4th plus 26x cubed plus 123x squared plus 316x minus 120 equals 0. How many answers do I have to have? I better have 4. I went ahead and did the answers in the calculator for you. One answer is x equals negative 5. That factor is x plus 5. So x equals negative 5 is an answer. This is x equals 1/3. 0.3 repeating is 1/3. That is 3x minus 1 as a factor. We have to divide both of them out. I'm going to use synthetic division on this one. But I can't use synthetic division on this one. Why? Because it's not just x minus something. It's 3x. So the first thing I'm going to do is I'm going to take the problem and I'm going to use synthetic division on it. So it's negative 5 goes into 326, 123, 316, negative 120. What should my remainder be if I do this correctly? The remainder should be 0. Okay, let's do the synthetic division. Drop, multiply, add, multiply. If I add, that's 68. Multiply, negative 340. Add, I get negative 24. Multiply, I get 120. That worked out nicely. Now, I've divided by one of them. Now I have to divide by the other one. But I can't do synthetic division, so I have to do long division. 3x minus 1 divided by. I'm going to use the answer that I just got. 3x cubed plus 11x squared plus 68x minus 24. What should my remainder be this time? It still should be 0. Long division. 3x into 3x cubed is x squared. Multiply. With this, we subtract straight down. That'll give me 12x squared plus 68x. 3x into 12x squared is 4x. That's 12x squared minus 4x. That's 72x minus 24. How many times will 3 go into 72? That's 60, so that's 24, I think. 24 times 3 is 72x minus 24. And look, it works out evenly. Which is better? So what's my remaining factor? It's x squared plus 4x plus 24. So now how do I solve this guy? I use the quadratic formula. X squared plus 4x plus 24 equals 0. How do I know it won't factor? Because if it would have factored, I would have already done that. Opposite of b, plus or minus square root of b squared minus 4ac, all divided by 2a. That's negative 4 plus or minus square root of. That's 16, that's 96. 16 minus 96 is negative 80 over 2. I need two numbers that will multiply to 80, and one of them is a perfect square. How about 16 and 5? So negative 4 plus or minus. The 16 will come out as a 4. The 5 is still inside. The negative comes out as an I. Never leave an answer like that. Reduce it down. Negative 2 plus or minus 2i square root of 5. So how many answers did I finally find? Well, a long time ago, I used my calculator and I found negative 5 and positive 1/3. That was 2 of the 4 answers I needed. I divided one of them out and got an answer. I took the answer and divided the other one out, and I got a quadratic. I took the quadratic, did quadratic formula, and found the other 2 answers. This is a long process. That's why we call it finding zeros the long way. But you will have quizzes and tests just like this to be able to do this. If you have any questions, come talk to me. Thanks, guys.